Shalom to you and welcome. In this video we will be looking at vectors. A vector is any quantity that has both magnitude and direction. What do you mean quantity? It could be velocity or acceleration, but it has to have magnitude, which is the size, the length, and then the direction is the south, west, east, okay, the direction where it's going. So the magnitude of a vector is the length of the vector. So a vector is symbolized, is written like this. It's written like a ray, but then with half, not two sides of the ray. So because it's not exactly a ray, it looks like a ray, it's drawn like a ray, but the difference is that it has a direction and magnitude. If the change, okay, we'll see more of that later. Let's go. Two vectors are equal if they have the same magnitude and direction. If they have the same magnitude and they don't have the same direction, then they are not equal. They could be parallel, but they are not equal. So they have to have the same magnitude and the same direction to be equal. And so when they are equal, we can substitute one for the other. All right. So here, you're given point P. These are ordinary points. So you need at least 2 points to make a vector. Just like you need 2 points to name a line or a ray, or so you need at least 2 points to make a vector. But this one or each of the point is not a vector by itself. It's the ray that connects two of them from the beginning to end. So we're asked to find PQ. So P is 3, 2. So it's drawn here, P. And then Q is 7, 1 is here. So this is the vector. But then the way we write it, this is the vector when it's drawn, like look like arrow. How do we write it as ordered pair? We take the change in horizontal change. So from P to Q, how much did it change in X and how much did it change in Y? Again, that sounds like slope. Yes, it's what it is, but then it's written like ordered pair instead of as a ratio. So we're going to write PQ as this change from 0, 1, 2, 3, 4. It changed 4 X and then Y, 1, 2, 3. So it's go 4, 3. If you draw that 4, 3, is gonna see is that it starts when you start from 0. So we start from 0. So these two vectors in blue and in red, they are equal vectors. It's just translated. So this will be kind of the original vector and then it's shifted down this way. So we are given the translation and then we write the original vector. So it's 4, 3. And that's what we're asked to find here. So that's the way we write it. PQ is simply 4, 3. So, okay, let me, oops, if I find my pen. All right, so PQ, let me do that vector, oops, is equal to 4, 3. Okay, and how you do it is just find the change. Again, if this is the, let's call it x1, y1, and this is x2, y2. So how we find this is just do x2 minus x1, comma, and then y2 minus y1, and that's how we get this. So 7 minus 3 is 4, and 1 minus 2, hold on, right, sorry, there's a typo error here. This is supposed to be, it's supposed to be -2. Okay, so Yeah, so 1 minus negative 2 becomes 1 plus 2. That's why we get 3. All right. So now this, to find the b is, you see, notice this is the absolute value. So what else reminds you of absolute value? Distance. Because distance cannot be negative. That's why we have the absolute value. So the distance is the magnitude. This is the magnitude. This is the name of the vector itself. This is the magnitude of the vector, which is the size of the vector. How long is the vector, the length of it? So we find the magnitude of the vector PQ. So it's going to be that change. Now we put it as the, in the distance formula. So it's going to be the square root of the same here, the changing, which we have already found. This is the change in x, which is 4, but we square it, plus the change in y, which is 3. So remember here, we usually put this, the change in x squared and change in y squared, with Pythagorean theorem because it is the distance. So that's the same thing we are doing here. So it's like, again, finding the change in y in x here is 4. And then the change in y here is, oh, what am I saying? Sorry, change in x is 4. And change in y is 3. Y is vertical, please pardon me. All right, so yeah, so we plug that in. Just simplify. 4 times 4 is 16, plus 3 times 3 is 9. So 4 plus 9, 16 plus 9. So that's 25. And the square root of 25 is 5. So that's the magnitude of this vector. How long it is? It is 5 units. So 5 units. And then here we are asked to find negative 2 times the vector. Now, when this is called scalar multiplication, negative 2 is a scalar. So you multiply this vector, you double it. So you double its x and double its y. If you double 4, it's going to be 8. If you double 3, it's going to be 6. So it's going to be, if it was positive 2 times the scalar, the vector is going to be 8, 6. But because it's negative 2, it's going to change direction. That negative, instead of going forward, it's going to change back. So that's why if you multiply by negative 2, it's going to double and change direction. Instead of going, northeast, it's going southwest. So this is the vector modeled. Okay, so that's the vector modeled. And now, how do we do it, the operation? So it's just, it's like I already done. First of all, multiply the, so we already have that vector, negative 2, vector PQ. So we are multiplying the vector, not the magnitude, so be careful. Just the vector itself, and the vector we already have is, so that's going to be negative 2, 4, 3. So negative 2 times 4 is negative 8. Negative 2 times 3 is negative 6. So both of them change because of the negative sign. Again, that's the vector in opposite direction. So we can add vectors. Addition is very simple. Just, this is the scalar multiplication. Here we're going to add this vector to this vector. But we're going to do the scalar multiplication first. So if we multiply this, that's what I did here. So multiply 3 times 1, you get 3. And then 3 times negative 2, you get 6. So that vector, and then before we add them, so we're gonna have so we're going to have vector 2, 6 plus vector, instead of having that, so we're gonna have 3, negative 6 again, because we have distributed here and then distribute here. So we're just going to add that to that. We get another vector, so 5, 2 plus, that is 5. And then we're gonna add 6 to negative 6, we get 0. So that's it. That's our sum of the vector, just add them. And that's when you model it. So this is like you start from with this vector. That's what I drew, that vector. This is 2, 6. 2, 6. That's this vector. You have to continue from where you stopped, and then you're gonna add on, go, x is positive, so you're gonna go right 3 and go down, because y is negative, go down 6. So from here you go 3, 1, 2, 3, and then you go down 6, 1, 2, 3, 4, 5, 6, and that's where I'm there. So suppose in a plane, a jet is flying, it started on this point, it went this direction, stop at a city here, and then turn back and have to make another stop at this city here. So this is, you can trace the whole distance, which is longer, but thinking of from where it started, it only went this much far away from where it started. So you add those, you get this, and that's our answer.